Okay, today we're going to work on slope. And this takes us back to Algebra 1 ideas, as well as Algebra 2. And then this will lead us to slight pre-calc stuff, and then into what we're doing now. Okay? So the idea of slope, just to remind us, is y2 minus y1 over x2 minus x1. The big deal of slope is how much something is changing. The change in y's over change in x. And this here is delta, the symbol for change, right? It's just a little triangle. For us, we talk about this as a rise over run. That's our Algebra 1 idea. But we're also going to apply this to the idea of average rate of change. So let me first take a look here and give you guys 2 points. Let's pick the points 1, 2, and 2, 4. Okay. 1, 2, and 2, 4. So the way we find slope is you could just count it. Rise is 1, 2, and the run is 1. Those are all classic way of saying slope. So our slope was 2, or 2 over 1, which is 2. We can also describe this again, as we mentioned, rise over run, which was rise of 2 and run of 1. Now, what does this really reflect? The idea of slope is how much something changes. And the big word here we're looking at is change. But whenever you have change, you have to refer change to something. Like a change in my bank account. How much did I gain over a period of time? You always have to reflect of what is changing over a determined period, a comparison over of time. So in this case of change, I've changed my y changed by 2 when my x changed by 1. So we look at this idea of change, a slope. But we can also refer to this as the average rate of change. Now, for a straight line, the average rate of change is actually the same as the slope of the line, because this is a straight line. And straight lines grow at a constant rate, a constant change. But let me draw you the same graph here now. And I'm going to draw 1, 2, and 2, 4. And this guy's going to take a beating. It's going to be like the stock markets. If you guys pay attention to stock markets, the tech stocks dropped, and then all of a sudden they increased. The stocks dropped, and then they increased. So for this graph, we don't have a constant slope. We don't. But we can still say, what is the average rate of change? What is the average rate of change here? Well, I know my points are 1, 2, and 2, 4. So overall, to get from 1 to 2, how much did we change? Well, we plug in our points, y2 minus y1 over x2 minus x1. We're comparing the y's over the change in x. For us to say the average rate of change, we're saying how much this change is happening over a time period. Whenever you hear the word rate, that is always referring to a change in something over a change in time. Rate is always based on a time for us. Or we can change it to another reference, but the idea is it's always based on this time idea. So what is the average rate of change here? Well, the y changes by 2 every time we change a y of 1. Now, could you say that it was always a constant rate of 2? No. Didn't we start losing here? Take a look. Didn't we start losing? And then all of a sudden we gained. But is this gain here exactly 2? No. Imagine if this was your bank account. You had lost some money, but then you have to gain even more to catch up so that we can have an average rate of 2. In this case, let's go ahead and write 4 minus 2 over 2 minus 1. Just to help you label this is x1, y1, and x2, y2. So as long as we have 2 points, we can compare them to see how much we've changed. Now, in Algebra 1, all lines, no matter what points you pick, will always have the same slope, the same change, because straight lines change at a constant rate of change. But when we have curved lines, and we'll take our example here of a parabola, we're going to pick our starting point 0, 0, because that's an easy point to start off with, 0, 0, and we're going to graph some points here, 1, 1, and 2, 4. 1, 1, 2, 4. And the parabola looks kind of like that. Would you agree with me that there is no constant slope? So let me spin this around. If I pick the first 2 points, that's one slope. But if I pick 2, 4, that's a different slope. And actually, every point in between actually changes our slope. And one thing that we want to realize is that curved surfaces don't have a constant rate of change. The change itself is changing as the curve is changing. At some points, the curve is more steep. That means the slope is higher. And at some points, the slope is more flat. So the slope is smaller. So our average rate of change changes depending on what 2 points we're comparing. So we're going to pick a point here. So our first idea, we're going to compare to point 1, 1. And then we're going to compare to 2, 4. So we're going to look for the average rate of change. Average rates of change, comparing 0, 0 to 1, 1. So 1 minus 0 over 1 minus 0. That's going to be 1 over 1. Okay. Overall, we had an average rate of change of 1. But comparing that to the second point, so it's y minus 4 minus 0 over 2 minus 0. Four over 2 is 2. That's our average rate of change. That's going to be definitely steeper. So one of the easy ideas here is that given any 2 points, if you give me the points, I can tell you what is the average rate of change. And the idea of average, it's not what it is what it's overall looking like. Now, the example is if I'm driving to Vegas, and let's say Vegas is 400 miles away, and I'm driving at 100 miles per hour. Vegas, baby, Vegas. Oops. Las Vegas is 400 miles away, and I'm driving, other way around. Let's come up with the answer in my head. And what if I get there in 4 hours? Vegas is 400 miles away, and I get there in 4 hours. Well, that means I was driving, on average, 100 miles per hour. But again, to be specific here, was I really driving at 100 miles exactly the whole way through? No, right? Sometimes you're driving faster. Sometimes you're driving slower. Sometimes you're just driving at 100. So sometimes we're a little high, sometimes we're a little low, but overall, we're about 100 miles an hour. Okay. Now, please don't drive 100 miles to Vegas. That's kind of fast. And I've had friends that went on accidents, and one friend, when they went to Vegas, the other lane, the car crossed the center divider, hopped into her lane, hit her car, and caused her car to rotate, like flip over like a bunch of times. They all survived, but they're all scarred up. Okay, be careful. Be careful out there. All right, so the average, right, remember this, average is the overall, not exactly at any one point, it's the overall change, okay? Now, when we are doing this, when we draw 2 points inside a graph, it leads us to what we call a secant line. Now let me draw another graph here. This graph will look kind of like a little bit more odd. I'm going to compare this line, this point, to a couple points along the way. So for us, a secant line was when a line crossed through the graph, okay, at 2 points. So this for us is going to be a secant graph, secant line. Now, we can come up with the average rate of change here. And if I give you the points 0, 1, I'm going to call this like 5 and, let's see, 5 and 4. Overall, what is my average rate of change? The formula is very simple. It's the same idea as slope. 4 minus 1 over 5 minus 0. What if I flip it? What if I write 1 minus 4 over 0 minus 5? Would it give us the same answer? Average rate of change. That would be 3 over 5, and this would be negative 3 over negative 5, which still would be 3 over 5. Now again, I would like to point out one thing, is that at every point on this graph, it doesn't really look like, whoops, like the slope is actually going to be 3 over 5. But we have a rule, and we'll talk about this rule later, that the average rate of change has to happen if this graph is continuous and differentiable. And we'll talk about that rule a little bit later, where we can find a point that would have the same exact slope as the endpoints someplace along that graph. And we'll talk about that later. Now, that leads us to talking about, if this is called the secant, 2 points on the graph, a tangent line is a line that touches the graph exactly once. Okay, so our goal of talking about secant lines is pretty much, this is from Algebra 2, so and Algebra 1, pretty easy. Now we're gonna transition that from a secant line to a tangent line, okay? A secant line to a tangent line. So I'm gonna show you guys this thing on Desmos. And the idea of this idea here on Desmos, there's a bunch of stuff, ignore the stuff on the left. But if you look here, this is a secant line. And this line here, this is my tangent line, okay? Look at the blue line. I'm colorblind. I'm figuring that's a blue. Let me zoom in a little bit. Change this a little bit. Projector mode. I want you guys to look at the blue line. That is a tangent line. It touches the graph exactly at one spot. While the secant line touches the graph exactly at 2 spots. So our Algebra 1 skills say I can find the slope if you give me 2 points. Give me 2 points. But here's something kind of interesting. Now pay attention to this. If the secant line, look at the 2 points. If the 2 points got super close together, it would look like the tangent line. Okay? The secant line is 2 points far away, obviously, right? Easy for us to see. But if I brought these two together, the 2 points got closer and closer and closer and closer, so close that they are literally sitting on top of each other. This would be the tangent line. And this will give us the slope of that tangent line. Okay, so our goal now in calculus is to say, if I want to find the slope of the tangent line, I can do that using Algebra 1. But these 2 points have to be so close together, that then we can estimate the tangent line now. Okay, that's our goal, and that's what we're going to do on this next point. So we're going to get from a secant line, and we're going to bring it to a tangent line. Why? Because the tangent line is actually the slope at that one point on the graph. A secant line is the overall slope, gives me the overall slope of two parts of the graph, the overall average rate of change. But what if I want to figure out what is the change, what is the slope of a line at this one particular point? Now looking at my example here, if it is a curved surface, all the slopes are going to change. Now let me ask you, on this right side, is the slope going to be positive or negative? It looks like it's going up, right? So every point on the right side here, I'm making money. The slope is positive. It's a positive change. But every point on my left side here, it's a losing factor. I'm losing ground. My y values are losing every time x goes forward. So we're going to have to calculate that because it's no longer an easy straight line. We talked about a straight line here. All straight lines have one slope throughout the whole graph. And it's predictable, rise over run. But once we have a curved surface, let me show you guys the dragon here. All the tangent lines all of a sudden change. If I'm over here, see my tangent line, my slope is positive. I'm gaining money in the stock market. Yeah, go NVIDIA. But at some point, it topples up, and all of a sudden I start to lose money. And that follows the tangent line. And I start gaining. And those are how much the graph is changing, not overall, not on average, but at one specific point. And that's what our goal is. Now, we're going to see this as, we know this part so far. A secant line is y, the slope of a secant line is y2 minus y1 over x2 minus x1. Okay? But what if the second point wasn't super far away, but super close? What if we tried making both points y2 minus y2 over x2 minus x2? What if we try making them the same point? The same point. Well, that's stupid, Mr. Ko. If I subtract y2 from y1, since it's the same point, wouldn't that just be 0? And x over x, x minus x would also be 0? This is undefined. This is also indeterminate. So our goal is to say this. To find the slope at a point, we are going to say the limit as h goes to 0 of f of x plus h minus f of x over, I'm going to write this long, x plus h minus x. I want you guys to see what I'm referring to here. My x1 and y1 and x2 and y2, I'm going to rewrite this as just x and f of x. And remember, y can be rewritten as f of x. And the second point is going to be a little bit away from x. And the f value is going to be plugged in a little bit away from x. Now to illustrate this in a kind of way for you guys to see, if I give you guys a point, we'll call this point x and f of x. Okay, x and f of x. Then if I move a little bit of h over, this new point will be x plus h. Hey, and if I plug in, if I look at another point, x plus h away, it should have a new f value. And this f value will be plugged in x plus h. So to find the slope of this, we say y2 minus y1 in this formula here. Okay. Let me pause. So why do we use h? The reason why we use h, it's like your parents talking about you. Let's say you have a sibling, and let's name Mark and James. Mark is 15, James is 17. Your parents could say Mark is 15 and James is 17, but let's say they like Mark a lot. They'll say Mark is 15 and that other kid is 2 years older. They'll say Mark is 15 and James is Mark's age plus 2. The idea is that instead of introducing two variables, we're just repeating the same favorite variable, x, repeatedly, and just saying how far the second kid is away from the first kid. In this case, h. So if I want to say, if let's say x was 5 and h was 2, the second point here would be 5 plus 2 is 7. And the emphasis is not on the second point being 7. The emphasis is more like how far away is the second point. And this is going to be important to us because I want you guys to look back here. Because how far is h away? H is 0. And the reason why we're talking about this is because when we tried this idea over here, where we said both the points are on top of each other, when I looked at my example of this tangent line, how far was the, oops, I lost the second one. Remember, how far was that second point? To get to the tangent line, they have to be the same point on top of each other. They have to be the same point. But when I look at this algebraically, this is not possible. You end up with 0 over 0. So we're going to cheat this, and we're going to make this into a limit. Now, we're going to come back here to the problem I wrote on my left-hand side, and we're going to do something to it. I'm going to simplify this, because what is x minus x? Doesn't that cancel out? The limit as h goes to 0 of f of x plus h minus f of x all over h. And that's the magic formula we're going to use to find change, to find the derivative at a point, to find our derivative function, to find the slope function. So we're going to use this guy. But in practice today, you guys are just going to use this part. Okay, so let's go give ourselves an example, and you guys can see how this was worked out. So let's say f of x is equal to x squared plus 2. And I ask you, what is the slope between 0, 0 and 2, 6? All right, well, if I plug in zeros, whoops, not 0, 0. This is 0, 2. That's 0, 2. Everyone changes to 2. 0, 2. Well, if I plug in 0, we should get 2, right? That's the graph. And if I plug in 2, we should get 6, because that's the graph. So we say 6 minus 2 over 2 minus 0 is 4 over 2. The slope is 2. And if I graph that out, 0, 2, 3, 4, 5, 6, 1, 2, 0, 2, 0, 6. We draw a parabola. This is a graph of a parabola. The secant line, the average rate of change would be up 1, 2, whoops, 1, 2, 3, 4 over 2, which is 2. But
Mr.
is this
Coffee,
slope?
please repeat the part where you found the slope.
Okay, so the way I find the slope is I write the simple version, y2 minus y1, whoops, y2 minus y1 over x2 and x1. And that looks pretty accurate here, where it's a rise, 1, 2, 3, 4, 1, 2. That's my slope of the graph. But the problem is, what if I was asking you to find the slope at 0 or find the slope at 2? Neither of the tangent lines look like the slope we came up with. So right now we're going to go ahead and we're going to push the slope forward. I'm going to ask you guys to find me the slope of the graph. Find the slope of the graph. And we're going to do this in a couple of steps. First, let's go ahead and set it up as our limit equation. We're going to subtract 2 points. So 2 points. But these 2 points aren't going to be 0, 2, and 2, 6. We're not going to use those 2 points. Let's say we're going to use 0, comma 2. That's our starting value. We'll worry about that in a little bit. And we're going to bump it a little bit an HOA. So my first equation is f of x is equal to x squared plus 2. So to write this as a point, it's x and x squared plus 2. You can think of this as like your x1, y1. But my shifted point is x plus h and x plus h squared plus 2. To rewrite this, this is my f of x plus h. It's the f version here with a little upgrade. And the upgrade changes the x only. Okay, to give you guys another example quickly on the side. If I write, okay, this is just another side off example, okay? If f of x is equal to x cubed minus 2x, this is a fancy one, okay? My f of x plus h, oops, not that too close, would be x plus h cubed minus 2x plus h. So every time you see x, you replace it with an x plus h. Every time you see x, you switch it with an x plus h. So we're going to write the slope formula here, where we're gonna say, like, our idea was, the idea was y2 minus y1 over x2 minus x1. So here's my y2 idea here, y1, x2, x1. So we're just going to copy x plus h squared plus 2 minus x squared plus 2. And we'll write this as parentheses so you guys can see all together. And we'll write x plus h minus x. So we're going to simplify this problem now. What is x plus h squared? Squaring a binomial is x squared plus 2xh plus h squared plus 2. If you're not sure, x plus h squared is x plus h times x plus h. And then remember, you do FOIL, front times front, front times back, back times front, back times back. Hey, look, I have 2 of them, Ma. So we have x squared plus 2xh plus h squared. Okay. Square the front, square the back, double the middle. We're going to minus, distribute the negative, x squared minus 2, all divided by x plus h minus x. I want you guys to notice the bottom, it's always going to simplify out to h. So we're going to stop writing that next time. We're just going to write h on the bottom to save time. On the top, I want you guys to find some like terms. X squared, negative x squared, positive 2, negative 2. So those will all subtract out. And we're left with 2xh plus h squared all over h. So our next move here, I'm going to write this out. You don't have to, but I'm going to write it out so you guys can all see it. They both have a common factor h. So now we can divide the h's out. Now, this is my slope equation for all my, you could say all my secant lines. So this is my slope for secant lines. Because remember, secants have 2 points on the graph. Tangents only have 1. Now I'm gonna make this a little trippy right now. Okay. So remember, we tried the point 0, 2, and 2, 6, and that gave us a slope of 2. You guys agree? So this is me saying, this is my first son, this is my second son. We call them out separately. But what if we just used, oops. What if I told you, so here is my slope equation, and I'm gonna say, here's a slope. So let me ask you the question, what do I need to plug into this problem to make this work? What do I need to plug in? I need an x and an h. So our previous example, we start off at 0, 2. That's my x and y. And we went to the problem 2, 6, I think. That was right? 2, 6, yep. So this is from our previous example. To use this equation, we don't use x and y. I don't care about y. I just need your starting x value, which is 0. And how far away is your h? Oops, check something. So if x is 0 here, oh sorry, what's my h? How far did it take me to get from 0 to 2? This is my h, right?
2.
It's 2. So if I plug in 2 times 0 plus 2, that's the slope of my problem. The slope is 2, which is what we had in our last answer. Okay? Now, this is just an overall idea here. We came up with an equation that tells me all the possible slopes of the secant line. Does this work truly? Let's go ahead and look at our equation again. Our original equation was 2, x squared plus 2. X squared plus 2. If we chose a point 0, 2, let's pick another point along the line. Let's pick the point, let's say 3. If I plug in 3 here, the point will be 9 plus 2 is 11. Okay, let's find the slope of these two values. 11 minus 2 over 3 minus 0. This is going to be 9 over 3 is 3, right? That's a slope. that we would end up with for the secant line. Now, if we use this formula here, that we said this guy's going to predict all the slopes, you plug in our x, you plug in the distance away. What's the distance away? It's going to be 3. Our slope is 3, which is what we said it was supposed to be. But when we're talking about tangent lines, how far is the second point? How far was the second point to end up with this tangent line? How far was this second point? The second point, to become the tangent line, look, the second point was it 2 points away? Was it 3 points away? Was it 2 points? Was it 4 points? It was 0 points away. Now, for us to do this problem, this is what we need to do. Take this, we say, hey, what if h went to 0 of 2x plus h? What if the 2 points weren't 2 spaces away, right? Weren't 3 spaces away? What if they were only 0 spaces away? So for limits, let me remind you, to solve a limit, you just plug in the limit. This becomes 2x. The slope equation for x squared plus 2, x squared plus 2, remember, that's my original graph here, x squared plus 2, is the slope of x squared plus 2 is 2x. So that's what we're going to do. We're going to be able to find the tangent line slope using this formula, where instead of taking 2 points that are far away from each other, the points are going to be right on top of each other, 0 distance away.